Your body can wake up tired even when nothing looks wrong. That is not random. It is your biology responding to signals it has been hearing for a long time. And once you see what flips that pattern, aging starts to look very different. Epigenetics is the layer that tells your DNA how to behave without changing the DNA itself. The code stays, but the instructions around the code can shift. That is where aging starts to look less like random breakdown and more like a pattern the body has been building for years. By the end of this, you'll understand the mechanism, why it matters for healthy aging, and why so many people misunderstand what is really happening. And once you see what flips that pattern, aging starts to look very different. Think about the last time you woke up already behind. The alarm felt too loud. The coffee barely helped. Your mind was slow before the day even started. That is not just a bad morning. It can be a clue that the body has been taking in the same signals for too long. Here is the part most people miss. Your cells are constantly responding to their environment, and those responses can change how DNA is expressed over time. And we can see a longevity research keeps coming back to epigenetic regulation, DNA methylation, and biological age markers. DNA methylation is one of the body's ways of putting small chemical marks on DNA that can change how strongly genes are read. The wiring is still there, but the instructions can shift depending on what the body keeps sensing. In plain terms, the same DNA can be read in different ways. Not because the code changed, because the reading pattern changed, and that leads to the unsettling question. If the pattern can change, what is actually doing the changing? The answer starts with something most people overlook. The body remembers repetition. Not only dramatic events, repeated ones. That is why stress, poor sleep, and other chronic signals matter in longevity. They are not just experiences. They can become biological instructions that nudge cells toward a different aging pattern. A late night now and then is one thing. A year of late nights is something else entirely. Think about a person who checks emails in bed, eats lunch at the desk, and falls asleep with the phone still glowing on the nightstand. Not of that feels dramatic in the moment. But cells do not judge drama. They measure frequency. The genome stays in place, but repeated inputs can change which genes are more active and which ones are quieter. That does not mean every signal has the same effect. It means the body keeps tallying what keeps showing up. And this is where the story gets interesting. If the environment can push the system in one direction, then the real question is not whether aging is written in your DNA. It is which signals keep rewriting the settings. The next layer is the cell's decision system. This is the network that tells the body whether to build, repair, conserve, or shut things down. Your cells read fuel, stress, and recovery like a dashboard. AMPK, the cell's energy-sensing pathway, tends to rise when energy is scarce, while mTOR, the growth and building pathway, rises when nutrients are abundant. That balance helps shape how cells invest in maintenance versus growth. A simple way to picture it is this. When the body thinks resources are tight, it leans toward repair and conservation. When it thinks resources are plentiful, it leans toward growth. Both modes matter. The problem is staying stuck in the wrong one for too long. This matters for longevity because chronic imbalance can push the system away from repair. In plain terms, the body can get locked into a mode that is bad at recovery. That is when aging signals start to stack up. And here is the trap. People often talk about aging as if one switch controls everything. It does not. The real question is which combination of signals keeps telling your cells to stay in the wrong state. The strongest signals are often not exotic at all. They are the repeated ones: movement, sleep, food, stress, and recovery. That is why this story gets more practical here. Studies on epigenetic age have linked lifestyle patterns such as physical activity, diet quality, and metabolic health with changes in biological aging markers, and intervention data suggests those markers can move over time. The text is educational and does not replace medical advice. Think about two people with similar jobs. One walks during the day, sleeps at regular hours, and eats in a way that does not keep the body in constant overload. The other sits for long stretches, eats late, and lives with broken sleep. The difference is not just lifestyle style. It is biological input. Exercise is a good example because it does more than burn calories. It changes cellular signaling, nudges stress response pathways, and can alter DNA methylation patterns in tissues that matter for aging. Sleep does something similar in a different direction. It gives the system a chance to settle, but that creates a bigger problem. If ordinary habits can shift the pattern, then the real mystery is not whether the body changes. It is why some signals calm the system while others keep pushing it toward acceleration. This is where the picture sharpens. The switch is not only about one gene turning on or off. It is about whether the body keeps a resilient aging pattern or drifts toward frailty. Newer research shows why that distinction matters. Some DNA methylation clocks line up more strongly with frailty and health risk than others, which suggests that biological age is not a single number, but a layered signal. Some clocks seem better at capturing health-related decline than simple calendar age alone. That matters for longevity, because frailty is not just weakness. It is a multi-system decline that reflects how well different biological systems still work together. And epigenetic acceleration can help reveal when that coordination is slipping. Picture someone who starts avoiding stairs, tires more easily after errands, and needs longer to bounce back after a minor illness. Those changes are easy to dismiss as getting older. Some DNA malady, the pattern often arrives before the label does. So the story is no longer, how old is your body on paper? It is, how much biological strain has been written into the system? And that leaves one final tension. If the markers can predict decline, can they also show which signals are quietly pushing it there? The switch is not only influenced by stress or movement, but by the broader environment that repeats itself every day: sleep, diet, exercise, and long-term exposure patterns. That matters because the research does not describe aging as a single irreversible track. It shows associations between epigenetic clocks and modifiable factors, and some intervention studies report shifts in biological age markers after lifestyle changes. Not miracles. Patterns. So the message is not that one habit magically controls everything. It is that the body is constantly taking in signals, and those signals can accumulate into a different aging trajectory. A short season of stress matters. A long season matters more. Think about a person who spends years in the same rhythm. Short sleep, sedentary work, low recovery, constant pressure. Nothing about that pattern feels like a single event. That is exactly why it is easy to ignore, and exactly why it matters. The science suggests that the body responds to repeated signals, which makes sleep, movement, and recovery especially important signals to protect. That leaves the final contradiction. If the environment can move the clocks, then the deepest question is not whether your DNA has a switch. It is why some people stay protected, while others seem to absorb every signal at once. Your DNA is not the whole story, but it is not silent either. A growing body of research links epigenetic clocks with lifestyle, frailty, morbidity, and mortality, which is why longevity scientists treat them as signals worth watching. That does not mean one habit guarantees a result. It means the body keeps recording patterns, and some patterns are associated with slower biological aging, while others are tied to acceleration. In other words, the record is real. The output is not fixed. Now the bigger point becomes clearer. The body is not simply aging. It is being shaped by the information it keeps receiving. That is why the same DNA can lead to very different outcomes over time. And once you understand that, healthy aging stops sounding like a vague slogan. It becomes a question of signal quality, repetition, and the long-term pattern your body has been living inside. That is the part most people miss. Your body does not age in isolation. It ages inside an environment, and that environment keeps leaving marks on the epigenome. The epigenome is the body's instruction layer above the DNA, made of chemical marks that help control which genes are easier to read and which ones stay quiet. That is the part modern longevity research keeps reinforcing. The genome matters, but the epigenome is where repeated signals, social conditions, and everyday exposures leave a biological signature that can shift the pace of aging. The body is always reading something, so the biggest misunderstanding is thinking DNA is fate. It is not. It is the starting material, and the signals around it help decide what gets expressed, what gets muted, and how resilient the system remains over time. Think about that in ordinary life. A rushed morning, a late dinner, a month of poor sleep, a year of stress. Each one looks small alone. Together, they become part of the biological message. So the ending is not a promise. It is a lens. If your cells are reading signals every day, then longevity becomes the study of which signals dominate, which ones fade, and which ones keep writing the same message into the system. Your body has been signaling this for longer than you think. Now you know how to see it. If this changed how you think about your body, subscribe and explore the rest of the series in the description below.